Hello everyone, welcome to Electronically Connected. So in this video, we'll be discussing a rather important type of adder which is called a carry look ahead adder. We'll be discussing what's the logic behind it and why it is used, and also we'll see how to construct it. So let's get started. The carry look ahead adder, also called as a CLA adder, is a very superior kind of an adder. Why is it superior? Because whenever we have to add big numbers, that is, let's say we have to add two 16-bit numbers, then the speed is of utmost importance, because what we care about is the creation of sum and carry at the end of our operation. Hence the speed is very important. Also in a CLA, as we have discussed in previous adders, that there is a lot of propagation delay. However, in cases of a CLA adder, that is carry look ahead adder, the propagation delay is much less. Now, what is a propagation delay? Each adder blocks that we have seen previously are made up of different kind of gates. Let's say AND gate, OR gate, or an XOR gate. These gates contribute to the propagation delay at the end. And in case of a CLA adder, the propagation delay is much less than the previously discussed adders. And also, each stages of our full adder does not depend on the carry out from the previous stage. We will discuss this more in detail. So, the carry look ahead adder is what is mostly focused on carry. Now, if we remember, let us first discuss the truth table of a full adder. So, we have our A bit, B bit, C in, and C out. We are not focused on the sum for now. We just focus on this carry out. So, where are the places where my carry out is? 1. So, we have this combination and these three combinations. So, the equation of carry out is A dot B plus A XOR B with C in. So one new aspect that we are going to be focusing on our CLA adder is that this carry out equation is divided into two parts. We have this one equation and this is the second equation. This A dot B is called as carry generator, and A XOR B with C in is called carry propagator. There is no reason behind this name. It's just that this carry generator is not dependent on any of the carry bits. But however, the carry propagator is dependent on the carry bit. So carry generator is called G, I for just general term, and carry propagator is called PI. So if you want to generalize GI, let's say I stands for any number of block of numbers that we are calculating. So it will be AI ANDed with BI. And for PI, that is a propagation delay, we have AI XORed with BI. So the carry propagation and the carry generator are the two equations that are very important for the role of our CLA. Also, we can write our Cout equation as a very generalized term using the carry generator and the carry propagator. So that will become, let's just say Ci. So it is A dot B, that is our carry generator. So we have Gi plus propagator with C. It's I and this is C in. So let's just say I minus 1, because it's from the previous stage. So that's it. We have our carry out equation for a generalized carry bit. So let's say N bit, which is Gi plus Pi dot Ci minus 1. So carry generator plus carry propagator ANDed with our previous carry bit. So if we have our two inputs, AI and BI, ANDing of them is going to give me GI, that is the carry generator, and XORing of my inputs is going to give me my carry propagator. So we have A and B. And there we have it, the circuit diagram for generating our carry generator bit and our carry propagator bit. Now let us calculate the carry out equations for each stage of our full adder for a carry look ahead adder. So we have the input C0 and then we have C1, C2, C3 and C4. Using the general equation that we have created over here, that is Ci is equal to the carry generator plus the carry propagator ANDed with the carry of a previous stage. So C1 is equal to G0 plus P0 plus C 0. That is C out of the previous stage. That is how we get C1. Similarly, now we have C2. So that is G1 plus P1 ANDed with C1. And we can substitute C1 from this equation. So we have G1 plus P1 ANDed with G0, P0 and C0. So we can see how carry 2, that is carry from the second stage, does not depend on the carry from the previous stage, that is C1. It only depends on the carry input. Then we have C3, which is G2 plus P2 and C2. Again, we can substitute C2 from this equation. So what we'll get at the end is G2 plus P2 ANDed with G1 plus P1, which has G0 plus P0 and C0. Again, we can see that C3 does not depend on any other carry, only on carry input, that is the carry 0. Next, C4, that is the last C out, we have G3 plus P3 and C3. Now substituting the value of C3 from the previous stage, we have a very big equation which is the G3 plus P3, and substituting C3 we have G2 plus P2, where C2 is as G1 plus P1 and we have C0 as G0 plus P0 and C0. This is C4. Again, so what we can observe is that C1 depends on C0, C2 also depends on C0 but not on C1, C3 depends on C0 only and not on C2 or C3 or C1, and C4 depends on C0 only. So this dependency of our carry out reduces the propagation delay. That means to generate C out, it does not have to wait for the generation of C1. It can generate C2 even though C1 is not generated using C0. And C0 is our main input, so it has to be present for the whole circuit to work. So we have, again, also if we have to generate C3, it does not need to depend on C2 or C1. It will only depend on C0, which is already present. Again, C4 does not depend on the generation of C3, C2 or C1. It only depends on C0, which is already present, and hence this reduces at the end our propagation delay. Next, let us see the whole circuit of our carry look-ahead adder using the logic of our carry bit, our carry propagators and carry generators. So this is the circuit of a 4-bit carry look-ahead adder, where we can see from the left hand side we have our carry input, that's the C0, which is the input for my full adder 0, where we have A0 and B0, and there it generates some 0. From A0 and B0, the carry generator and the carry propagator are generated, and with the help of these two equations, that is the G0 and the P0, we have our C1. Then again, in a full adder 1, we use C1, A1 and B1, and we generate our carry generator and a carry propagator, and a C2 is generated, which is not dependent on C1 but on C0, and we have our sum 1. Again, from full adder 2, we have A2 and B2 as our inputs and C2 as our input, which generates our carry generator and carry propagator, and hence it generates a sum and the carry. Again, the carry C3 is not dependent on C2, C1 but only on C0, hence reducing the propagation delay. And next, on the last stage, we have our full adder 3, which has our inputs A3 and B3 and the input of carry 3 from the previous stage, which generates our carry propagator and a carry generator, and which at the end we have our sum out and carry out for the whole 4-bit carry look-ahead adder. This carry look-ahead adder can be generated for different kinds of bits as well. Another point that I want to mention is that the carry look-ahead adder has an IC number of 74182. With this, we come to the end of our video. Thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.